Hey there. Glad you stopped in. Thermite here. For the foreseeable future, the AI voice will have to do. So, getting right down to business. This is a quick prototype vehicle with tank tracks. Today's video will cover a controllable electric tank. This will be mainly centered on the making and testing of the microcontroller. Here you can see a simple setup consisting of medium electric motors, a large battery, a seat, and a dial to show our speed. We have the motors hooked up to the battery via the electric logic, and the tracks hooked up to the motors via pipes. There is currently no input to the motors to control them, and simply hooking them up to the seat won't gain the control we want. For this we need a microcontroller. The microcontroller editor is found in the upper right of the build menu. Now we find the first bit of the editor, a way to enter a name and description for our microcontroller, as well as adjusting its size. For this particular microcontroller, 1x3 will do perfectly. For any microcontroller, you need enough space for all the logic nodes. Now let's add a name and save our microcontroller so we can find it later in the build menu parts inventory. Once we've saved it, let's get going with the logic. Currently, nothing shows up in the blue grid. We need to add logic nodes to our microcontroller, so they'll show up here. We need to head to the logic tab, not to be confused with the logic menu. Now we add nodes. We'll make a composite input node for control input, and we'll make 2 number outputs for each motor. Now that we have our nodes, they should show up in the logic menu. Great success. Let's lay these out and start the real fun. Composite is a way of transmitting multiple signals through one node. They have to be separated out in the microcontroller with composite reader and writer logic blocks. So let's grab a composite reader. Drag, select, and hit Ctrl-C then Ctrl-V to copy and paste it. We then need to select the channel that we want to read. I already know that A and D are on channel 1 and W and S are on channel 2. Notice I put the reader for channel 2 on top. So, once this is connected to the seat, it will recognize the composite inputs on channels 1 and 2 and output them from the readers. Here's how you can see all the composite channels for the seat. Go to the Composite Logic tab and hover over the seat's node, and it will show all of its outputs. Composite is a great way to save space on your builds and make use of instrument panels and other composite-only components. It's like a big bundle of 64 wires. 32 are numbers and 32 are Boolean signals. Anyway, back to our microcontroller. Let's grab a property slider. Property logic allows us to change some values without having to go through so many menus. The purpose of this property slider is to adjust motor sensitivity easily. We'll set the minimum value to 0.1 and the maximum to 1 with the rounding set to 0.05, that is 5%. For now, we'll set the value to 0.1. Now, the magic begins with the numbers. For that, we need a couple 3 input function blocks. We'll connect our composite readers to the X node and the property slider to the Y node. We'll enter the very simple equation X times Y. This multiplies the throttle by the selected motor sensitivity. After that's done, we'll need a little more space to place a single input function block and some add blocks. Connect the nodes as shown. Now that everything is hooked up, let's review that we have everything correct. It looks like all the nodes are hooked up gooder than a chicken pot pie in a cast iron skillet. So let's search it up in the build menu parts inventory. And there it is. Now let's place it down, hook it up and test it. I'm sure nothing could possibly go wrong. Don't forget to connect the composite node. It's easy to forget since it's under a different tab than all the rest of the usual logic. Okie doke. Let's spawn it in and see how badly I messed it up. Ready? W. Now S. Perfect. Now D. Huh. Now A. Something's off here. Back to the workbench we go. Let's check our connections. These are fine. Back into the microcontroller now. Well, these all look good too. Wait, found it. This function should be -x. That should solve our problems. Let's save it and spawn it in again and see if we got it right. W. S. A. D. It's a bit slow, but that's where the motor sensitivity comes into play. Let's crank it up and see how that affects us. Okay, now it handles like a caffeinated rodent with ADHD. Parkour. Parkour, parkour. Parkour. So, you can choose whether you want a lot of power or a little power with the property slider. My preference is usually a little less speed and more control. Also, lowering the sensitivity to less than 0.2 causes huge amounts of energy savings, though it considerably impacts your acceleration. So, that's part 1 of the Stormworks tank tutorial. In part 2 I'll show you how to make a diesel-powered tank with a modular engine. If you have any questions, just ask. I won't claim to have all the answers, but I'll give it my best shot. See you next episode.